Hello, everybody. This week, you guys are starting your data unit, and we're talking about statistical data. Statistical data always has to be quantitative. So every year, you guys take a milestone test, and you are answering questions with words. However, we always turn all of your answers, which were words, into a score. Quantitative data. So we can, and we use that a specific number to see if you were considered that you met your standards or you were proficient or you still needed some extra interventions in order to help you reach those standards. So that's what statistical data does. It gives information about a group of people. So in other words, we wanted to know how sixth graders performed on the Georgia milestone last year, or fifth graders. That would be considered statistical data. All right, so let's just start going over these, and I'll just talk through it as we go. Statistical data helps you draw inferences or conclusions about the characteristics of a population. So grocery stores will use statistics to learn about the characteristics or the habits of their shoppers. So for example, when they run their data, they want to know, okay, are shoppers more likely to pull cereal from eye level, or are they going to reach up and most shoppers get the cereal off the top shelf or the bottom shelf? They want to know where their shoppers, how they shop, what parts of the store they go to most frequently. If you're at the checkout, what items will sell fastest? Probably the cheap candy. If you're standing there and you're hungry, you're going to grab candy that's not very expensive, and that's why they put it there. Not because it helps you, but because it helps them. And they know the placement of everything in a grocery store based on statistics. They have done lots and lots and lots of studies to see what store setups can be to make customers spend more money. All right, anyway, so in order to gather statistics, if you are going to go out and research or conduct a survey, there are 4 things that you have to do in order to gather statistical data. The first one is your answer has to be, your question that you come up with must be answered by data. The second thing you want to do is design and implement a plan that collects the appropriate data. So for example, you want to make sure wherever you go to collect your data, you are in a place that would not give biased answers. For example, if I wanted to know what are students at Davis Middle School, what are their favorite sports? But I only went to a basketball game and asked people coming and going out of the doors, what's your favorite sport? Well, that is not a good plan. I need a different plan. I need to be able to collect data that's not going to be biased, right? Once I collect all of my data, I need to be able to analyze the data, usually using graphs, which is the easiest way you can look at it. You can see what it looks like visually. You can find the mean, median, mode, the range. You can find out all of the information, and then you're going to interpret and compare the data. You're going to come to a conclusion. You're going to make an inference about the population that you just gathered the data from. In order to gather valid data, valid means something that's trustworthy. So I could ask questions. If my results are not valid, that just means that no matter what the results say, it doesn't really mean anything. You have to make sure your survey and your collection is giving you valid information, valid data. First thing is the question must be unbiased. So if you're asking a survey question, you don't want to use a lot of adjectives. For example, if I walked up to you and I said, hey, do you like yummy pepperoni on your pizza, or do you like disgusting anchovies? Well, my question is biased. It's going to make you probably say pepperonis, first of all, because anchovies are gross. But not only that, but because you know my opinion from the question that I'm asking. So you want to make sure you ask a very general question, not general, but a question without a lot of adjectives, right? Don't use words that influence the person that you're asking. Your answers must be varied and clear. So for example, if I asked you, did you read a book last night? Well, the answer can only be either yes or no. So that's not going to give me a lot of varied answers when I ask people. However, a better question would be, how many minutes did you read last night? So let's say I want to know how many average minutes does middle schoolers spend each night reading? Well, when I collect my data, I would ask that question, how many minutes did you spend reading last night? I could get a lot of different answers from 0 to 120 minutes and anything in between. So the other thing you want to make sure is that the answer is clear. For example, I'm not going to ask a question about something that you did 4 years ago and you have no idea what the answer is. For example, I'm not going to say how many episodes of a particular TV show did you watch in the year 2015? You might go, oh, I don't know, around 30. And really you're just guessing. So the information I gather is not going to be valid at all. I mean, it's just people guessing, I don't know, maybe 20, maybe 100. I don't really know. So you want to make sure a question that you're asking, the answers are reliable, clear, and the answers are valid. Don't ask yes or no questions. Don't ask questions that people have to guess their answers. All right, the survey must be random. That's kind of the same example I used earlier. Don't stand at a basketball game and ask people their favorite sports. If you're standing at the front of the school and you ask every third person that walks in, what is your favorite sport? That is a random survey. You have no idea what every third person is going to say, what they do on the weekends, if they're involved in sports or not. But if you stand at a basketball game, the people there probably like basketball. Maybe not all of them, but most of them probably like basketball. And then the survey must describe a population. So for example, you can ask one person a question as part of a survey, but don't ask one or even maybe just two people questions and say, okay, I've conducted my survey. No. It's got to be representative of a population of people, not just one or two people. All right, now when you get your data, like for example, the graph here on the left, someone has gone around and said, how many brothers and sisters do you have? Maybe the overall question is, what is the average number of siblings let's say in my Sunday school class? What is the average number of siblings of the members of my Sunday school class? Well, the question would be, how many brothers and sisters do you have? Well, once the data is collected, here on the left, we have shown those results in a dot plot. Well, both of them actually are dot plots. We don't really know what the question on the right says. It doesn't have a title. Let's say maybe it's, how many animals do you have? Well, the answer that occurs the most is 4, right? But we still have these two way out to the right. Somebody might have 13, maybe someone has 14. Maybe they're like baby chicks or something, right? Well, when you see the data, once you collect it and then you organize it in a graph, you can kind of see what's going on. So here on the left, this data looks very symmetrical. The one on the right, you can see that, well, a lot of these answers are very close together, but then we have these two that are far away from the other sets of data. So you can see that the information on the right is more spread out than the information on the left. So if you want to know what's the average, the center, that means you're asking for the mean. So basically I would add up all of these numbers. I would add 0 plus 0 plus 1 plus 1 plus 1 plus 2 plus 2 plus, I'm going to add up all those numbers and divide by how many there are to figure out what the average is. If we're talking about how spread out data is, we can see it clearly from these graphs that the data on the right is much more spread out. It has a larger spread than the data on the left. One way is to find the range. You take the highest number, in this case it's 14, and you subtract from it the lowest number. So the range here is 14. The range on this graph is only 4. So the data is much less varied on the left. We notice the shape. Like I said, this shape is very symmetrical. So not a lot of crazy answers over here. I mean, they're not crazy answers if you have an outlier, but you can see that the data is very symmetrical, but this data is definitely not symmetrical, right? You would say that this data is skewed to the right, because if I drew a shape, let me do that. If I drew a picture of my data, you would go, oh, it skews to the right. So most of my data is what's the word? Gathered closely on the left. I can't think of that word. So that means it's skewed to the right. However, if I draw a picture of this data, oh my goodness, look how symmetrical it is. I could draw symmetrically. All right, so what are the measures of center? If we want to know about the average, we basically want to know two things. We want to know about the mean, which is the average, and the median. We want to look at the middle of the data. So I have some data, a data set down here, and so we're going to find the mean and the median of this data set. So I have 1, 2, 3, 4, 5, 6, 7, 8 numbers. So I'm going to grab my calculator. So to find the mean, I'm going to add up all those numbers, 96 plus 95 plus 70 plus 24 plus 25 plus 100 plus 20 and 30 is 50. And I got 460. And then to find the average or the mean, I'm going to divide by 8 because there are 8 digits in the set. So my mean is 57.5. That's my mean. So on average, if these were scores, on average, or the average this person has in their class right now is at 57.5. Now the median, it's very important to do this first. You have to put these numbers in numerical order, okay? If you just find the middle number the way it's written, that's not going to tell you the true median. You have to put them in numerical order. So the smallest number is 20, and then we have 24, and then we have 25, and then I have 30, and then 70, 95, 96, and 100. Now I have 8 numbers. So that means 1, 2, 3, 4. I have 4 lower numbers and 4 higher numbers. If I had an odd set of data, I would have exactly 1 middle number. So I would just circle that middle number and that would be the median. But because I have 2 middle numbers, I actually am going to add up those 2 middle numbers and get 100, but then I have to divide by 2. So 100 divided by 2 is 50. So the median is 57.5. The median, the middle of my data, is a 50. So those aren't too far apart, right? Those are pretty close together. Now, when we talk about spread, let me erase these numbers. We talk about spread, we're talking about 2 different things. We're talking about, when we're talking about spread, we want to know how varied the data is. So we're saying that this girl or this guy has earned a 57.5. We want to know if all of the grades are very close to that average, or is she all over the place? Does she make a 20 and then a 100? Well, we can tell from the data that she does. But the way we talk about, the reason we want to talk about spread is because we're talking about how varied the data set is, okay? So we're talking about 2 things. We're talking about the range, what separates the biggest and the lowest scores. And we're talking about what we call the mean absolute deviation. So the first one is the range, which simply means you take the smallest number and you subtract it from the biggest number. Well, the lowest score is 20. The highest score is 100. So that means the range is 80. So that means, especially since these are scores, her scores are very spread out, right? If the range was only like 10, that would mean that her grades are all very close together, within 10 points of each other for the whole semester or whatever it is. So that range right there tells us that we have data that's spread out. She's not very consistent in her scores. Now, the mean absolute deviation is an average of how far each data item is from the mean, okay? So let's say we had another student who made also a 57.5, but let's say that particular student also has 8 grades, but their lowest grade was a 50 and their highest grade was a 64. A 50 is 64. If they have an average of 57.5, and they only have a range of 14 from 64 to 50, that means that they are very, very consistent. The data is not very varied. All right, so what we're gonna do to find the mean absolute deviation, there's several steps. The first step is to find the mean. Find the mean. Well, we already know the mean because we already did that. Number 2, find the difference. Find the difference. What does difference mean in math? Subtract. Find the difference of each data item. Data item and the mean. So basically that means we are finding the difference between each of these numbers and 57.5. So we're going to take, and we always want a positive number. That's why the word absolute is in there. Remember, absolute value is always a positive number. So 96 minus 57.5 is 38.5. The difference in 95 and 57.5 has to be 37.5. The difference between 70 and 57.5 is 12.5. The difference in 57.5 and 24 is 33.5. So this would be 32.5. 100 minus 57.5 is 42.5. 20 from that number is 37.5, and 30 from 57 is 27.5. All right, so these represent the difference between each data item and the mean. And the last step is to find the mean or the average of the differences. So now we're going to find the average of these differences. So we're going to add up 38.5 plus 37.5 plus 12.5 plus 33.5 plus 32.5 plus 42.5 plus 37.5 plus 27.5. And I got 262. There's still 8 numbers. So the mean absolute deviation is 32.75. So that number is big because these are scores. This person's average for the class is 57.5, but the mean absolute deviation is 32.75, which means on average, each of her scores is 32 points away from her average. So that's very varied. Now, earlier I was talking about what if a student also had a 57.5, but their scores ranged between, I think I said 50 and 64. If we found their absolute mean deviation, that number would be much smaller than 32.75. So the larger the mean absolute deviation is, the more varied the data is. And that's what that means. Seems like a lot, seems very complicated, but that's what it means. It talks about the spread of the data. All right, so I'm going to show you 2 things. We're going to draw a dot plot, and then with the same information, we're going to draw a histogram, okay? So a dot plot just simply means I'm going to draw a number line from the smallest number to my largest number, and I don't skip any numbers. So I see a 0 and I see a 7. So I'm going to, just like a number line, I would not skip numbers. 0, 1, 2, 3, 4, 5, 6, 7. And I could use dots, thus the name, but I just prefer to use X's because I don't know, I just do. All right, now some people try to count up all the zeros and then all the ones and all the twos, but it's so easy to skip a number that way. So I'm just going to put X's over the numbers in the order that they're written. So the question was, what is the number of siblings that you have in my third period class? And so these were the responses. So I have 2, 1, 2, 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 0, 2, 1, 0, 2, 7, 5, 3, 7, 5, 3. Oops, I hit a 3 instead of a 5. Did y'all see that? All right, 1, 1, 1, 1, 1, 1, 2, 6, 3, 2, 6, 3, 2, 0, 4, 2, 0, 4, and then 1, 1, 3, 1, 1, 1, 3, 1. All right, so that's my dot plot. Now, in order to make it a good dot plot, I would need a title. So we're going to put number of siblings. Now, very quickly, when I look at this, I can tell the most popular answer. So that word is called the mode, the number that occurs the most. So I see that 1 is the most popular answer. I also see that most of my data is spread out between the 0 to 3, but then we do have a graph that skews to the right because some people have large families, 5, 6, and 7 siblings, right? But most of my data is concentrated, that's the word I was looking for earlier, to the left, which means that the graph is skewed right, it's the opposite. But anyway, so we could tell, what does every X represent? X represents the people that we asked the survey to. So if I counted the number of X's, that would be how many people answered my survey question. What do these numbers on the bottom mean? Those are the number of siblings. So 1, 2, 3, 4 people had 3 siblings, right? All right, so that's my dot plot. Now I'm going to take the same information. I'm going to create a histogram. So a histogram looks a lot like a bar graph. Few differences. One of the differences is that the numbers on the x-axis, the bottom axis, it has to be numbers. It can't be words. So you wouldn't say, what is your favorite pizza topping and make a histogram. That's not a number. You have to have a number as a response. The other thing is that not only do you have to have numbers on the bottom, but they have to be in equal intervals. So I could do intervals of 2. I could do intervals of 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I could do that. Let's do we'll do intervals of 2. So the first interval will be 0 to 1. Now the second interval can't be 1 to 2. I've already used 1, right? So the second interval has to be 2 to 3. So what would the next one be? 4 to 5. And the last one will be 6 to 7. Now these are the number of siblings, right? Now, what will my y-axis, what will my vertical axis show us? It will be the number of people that we asked, right? Number of surveyors, number of people. Or you can always say frequency. Number of people that answered our survey is a better answer. All right, so what would be the highest group? Well, our biggest group is going to be 0 to 1. Don't you think? Maybe 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And this one's going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So since 11 is our most popular answer, we definitely have to go up to the number 11. Now we asked 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 25 people. Well, if I counted all the way up to 25, but my most popular answer was only 11, that would mean that almost half or more than half of my graph would be completely empty. So you want to fill up as much of your graph as possible. So you want to take your most popular answer and you want to make sure you have through that number at least, maybe even one above. So we're going to do 1, 2, 3, 4, 5, and you want to try to, I would use a ruler. If you were in my classroom, we would use rulers, we would use graph paper. I would tell you to make sure the space between these dots were all equal, but I'm just sketching it right now. But anyway, all right, so 2 things, histograms. The bottom has to be numbers, have to be intervals of numbers. The second thing is that the bars all touch. In bar graphs, the bars don't touch. But we already figured out we have 11 in our first group. So let me use a different color. Why not? So, ooh, you guys, one of these days I'm going to take a class, how to draw a straight line. All right, so our first category, our first interval has 11 answers. 11 people have either 0 or 1 siblings. Now, if I didn't have my data and if I didn't have my dot plot, I wouldn't know of these 11 how many have 0 and how many have 1. So that might be what you might call a disadvantage of a histogram. But since we have our data and we have our dot plot, we could figure that out. All right, what else? 2 to 3. What did we say the number was? I already forgot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So a very popular answer as well. Like I said, if you were in my class, we would be using rulers, all straight lines. We'd be using, making sure our bars were about the same width apart. Some people like coloring, some people hate coloring. All right, what about 4 to 5? We only had 2 people, so bigger families, right? So big families. Only 2 people said 4 to 5. And finally, 6 to 7, we'll use light orange. There we go. Awesome. All right, so there is my histogram. So histograms look similar to bar graphs, several different differences. All right, so anyway, so that's it, you guys. So like I said, without the data and without the dot plot of this group right here, I wouldn't know, okay, how many have 4 and how many have 5? Maybe both have 4 or maybe both people have 5. We just don't know, right? So that might be something that histogram is lacking, but it's still a good way to organize data. You take all of your data, put it into equal intervals, and then show the distribution of the data that way. All right, so that's all for my examples. So hopefully that helped. And I wish I had some more problems for you guys to practice making your own. I would really prefer you to do that. In fact, why don't you ignore my graphs and use the data here and make your own and just practice making those. Like I said, if you were in my classroom, we would spend a day making graphs. All right, you guys. Well, this week, when is our Zoom? Let's see. This week, the 15th at 10 o'clock. So come on back. Make sure you do your Delta Math assignment, which I believe is on Friday. Make sure you get that done. There's 20 questions. And if you need me before Friday at 10, you know how to contact me, right? All right, you guys have a great week, and I will see you guys at 10 o'clock on Friday.